Hi guys, it's Mark Glenn, the GMAT mentor, here to make the GMAT make sense. So let's talk about data sufficiency. It's a question type that often gives people trouble, but it's also a question type where you can really make up points and time if you know what you're doing. And in particular, it's good to be able to avoid calculations and use more reasoning-based techniques to solve. This can really help you out. So here's a great example right here. Let's take a look. So the total cost to charter a bus is shared equally by the people who went on a trip. The total cost was $360. So we can represent that pretty simply by saying number of people times the cost equals $360. And it's asking for the number of people. Okay, so far so good, right? Statement 1 tells us each person paid $9, so the cost is simply $9. We can plug that into our equation, and we know that 9p equals 360, and we can solve. Not that it's that difficult, but we don't even need to solve here, right? Of course, if we do, it's p equals 40, but in any case, we know that there's exactly one answer, so statement 1 is sufficient, and we can move on. Okay, statement 2 is actually considerably more difficult, right? In fact, when you first look at it, it seems like it might require algebra. But before you actually start diving into algebra, let's think if we can be smarter about it, right? What can we do here to actually avoid putting in a lot of calculations? So I think a great way to think about this is to think about extremes. So let's say, what's the smallest number of people we could possibly have on this trip? 5, right? Because it's saying that 4 or fewer people had gone on the trip would give us another result, right? So let's say we had p equals 5. Then the total cost per person would be 360 over 5. No need to actually calculate it, right? And then when we take those 4 people away, we know that the remaining person is covering the entire cost, so $360. Okay, so clearly this increase in cost per person is way more than $1, right? So we can't have 5 people. It must be way more than that. Okay, let's think about what would happen if we had a large number of people. So let's just say p equals 1,000. Obviously not very realistic for a bus, but that's okay because we're just trying to test possibilities. So in this case, the cost per person would be 360 over 1,000, so something less than $1, right? And if we took 4 people away, the cost would be 360 over 996. Not much difference, and also still less than $1, right? So we know that clearly the cost has not gone up by $1. So what did we learn here? We learned that as we increase the number of people, right, taking 4 away has a smaller and smaller impact. So there must be some point along that continuum from 5 people to 1,000 people where taking 4 people away causes the cost per person to increase by exactly $1. And that's it. That's all we need to know, right? We know that there's that one point, that one number of people that will work, and so statement 2 is sufficient, and we can pick our answer choice, which is D. Now, let's say that you weren't quite clear on that, right? We can still solve it with algebra, but it's going to be a little trickier. So that's why we always want to look for these reasoning-based techniques if we can. But let's take a look at how we would do it with the algebra. So first I'll clear off some space here. 4 fewer people gone on the trip, so that's simply p minus 4. And then cost per person went up by $1, so that's c plus 1. And we know that that's equal to the original total, right? Which was PC, or $360. Okay, now we can go ahead and do some algebraic techniques, right? So we know that we have 2 binomials. Let's FOIL it. So PC be our first terms, plus P our outside terms, minus 4C our inside terms, and then minus 4 for our last terms, and that's going to equal PC. Now we can see that, if we just subtract PC from both sides, that's going to simplify it, leaving us with 0 on the right side. But now we're left with one equation, 2 variables, right? Which is not an ideal place to be, but we still have that 360 we haven't used. So to use that, we want to multiply everything by either P or C. Since we're solving for P, let's multiply by P. So multiply P times P, that gives us P squared, minus 4PC, minus 4P equals 0. Okay, now we can plug in that 360 for the PC. So we have P squared. Let's pull in the 4p first, minus 4p, and then we have our minus 4 times PC, or minus 4 times 360, right? And now we have a quadratic equation, which we know how to solve. Not an easy one to solve, right? But if we go ahead and make our brackets, we can see that even now, even though we're doing algebra, we still want to look for, logical shortcuts here, because we know that since this last term is negative, we'll have one positive and one negative here, which means that we'll have one negative and one positive result, meaning that there's only one result that works, right? Because we can throw the negative one out. Can't have negative people. So only positive works, so we know that this is sufficient. However, just for illustration purposes, let's carry it through all the way. So we know that this 4 times 360, that's going to be minus 1440 if we work that out. And again, I'll shortcut a little bit by just jumping to what the right factors would be, which is 36, positive 36, and minus 40. And of course, if we work that out, that tells us that P is going to be either negative 36 or positive 40. Again, can't have negative people, so we'll cross out the negative 36, and we're left with 40 people for our answer. So statement 2 is sufficient. Multiple ways to solve, but again, much smarter if you can use a reasoning-based technique to avoid doing a lot of calculations. So hopefully that helped make the GMAT make sense.